It is my honor to introduce a man who really needs no introduction because he was introduced yesterday. So, Dr. George Hearn.
Hey, thanks, Charlie. And hello again, and thanks for your attention today. I'll tell you a bit about a project that we're working on right now at the University of Colorado. This is National Cooperative Highway Research Program Project 1436. So Wasim Dekelbab is our manager. We've got a program panel that includes Sarah from Illinois. We've got Oregon and California represented, Arizona, Florida, Richard Kerr is our guy there, Virginia, Mike Brown, and New Jersey. Nat Kasbacher is on the panel. And I may have forgotten somebody, so I kind of apologize, but a nice geographic distribution of people. The purpose of the project is to draft a guide that AASHTO will be asked to consider as a manual for preservation of bridges, for bridge preservation actions. So, whether AASHTO adopts it or not is an entirely different process, but the thing begins with getting a contractor, in this case the University of Colorado, writing the guide and writing it in a AASHTO manual format, and then seeing if indeed the 50 states want to adopt this thing. There's a link here. This will take you to the site that NCHRP maintains, that TRB maintains, and it's got the abstract of the project, identifies the contractor, CU, and I guess shows the progress we're making so far. The project is still pretty new. We started in November of last year, so we're not quite 11 months into it. We've been through phase one, which was a literature search and looking at existing work of states in bridge preservation. And we're now collecting data from states to give us a good, realistic basis for preparing examples on a programmatic process to select preservation actions and then to find out whether there is indeed a benefit, a financial benefit to doing the preservation. So I'll tell you a bit about the project in this talk. One of the first things we address is which bridges ought to be preserved. Preservation is not for all of your bridges for a couple of reasons. Some of your bridges are worn out. There are condition issues. But other bridges, for various reasons, are not bridges you want to keep. So that's the idea of this chart. Over on the left part, we've got four categories. We have a condition category, capacity, vulnerability, and then TIP, Transportation Improvement Plan. So if your bridges are in poor condition, especially major elements in poor condition, then you need something more than preservation. So there's a lot of your bridges are in good or fair condition. They can be in your focus for preservation, but other bridges should be receiving other attention. There's capacity issues. Load capacity is one. So certainly if a bridge is posted, you need to do more than just preserve it. But a bridge could meet legal loads, but it's on a route where the owner wants to run overweight permit loads, and so you'd like a stronger bridge. And so preserving that bridge in place is a mobility issue, and so you may want to replace it or substantially modify it to strengthen it. There are vulnerability issues. Earthquakes one, scours another. So if a bridge has these problems, it needs more attention than just deck sealers and new joints. So it may not be in your preservation category. And then transportation improvement plan for any of those reasons, condition or capacity or vulnerability or anything else. The community wants a new bridge or a different type of bridge. There will be structures that are indeed in the program. They may not be replaced for a few years, but they're on the list. They're working their way through the process of project development and finally replacement. So certainly anything that's already in the TIP is not one you're going to worry about preserving. The union of all those, or the overlay of all those, gives us a lot of bridges to preserve. Most of your bridges are, the condition's okay, capacity's okay, they're not vulnerable, they're not programmed. So you want to preserve those, but then there are bridges which have failed at least one of those categories, and those are the ones you don't preserve. By focusing only on the bridges to preserve, we get our performance measures better. We're not getting distracted by the SD bridges when we're trying to figure out how well preservation is going. We get our budget estimates better. It also changes the conversation about what actions are we going to consider as preservation. So here's that same slide, but kind of put in words. So we look at the condition of the national bridge elements, and if they're in good condition, we're looking at preventive maintenance actions. If they're in fair condition, we're looking at corrective maintenance actions. If they're in poor condition, we're looking at more than preservation. So we need some repair, rehab, replacement maybe, right? We look at the condition of the bridge management elements. So these are the coatings and wearing surfaces and so forth. Those BMEs could indeed go into poor condition, and it's still a preservation issue. Replacing a wearing surface is a preservation issue. Then capacity, if it's adequate, this is a bridge we'd like to preserve. If it's not adequate, we need a different solution. Vulnerability, if the bridge is not vulnerable, if it's robust, it's one we want to preserve. If it's vulnerable, we don't. This could all be expressed as remaining life. Do we see this bridge still being a good bridge to have in service on its particular route and in its particular location? Is that true for 20 years or more? Is that our best estimate? It's a preservable bridge. If we're looking at any aspect of this bridge and we'd like to be rid of it, or the owner would like to be rid of it within 20 years, then it's probably not part of the preservation population. We identify preservation actions. This will be a large part of the guide that we're preparing. We've got preventive actions. These include things like cleaning and washing and removing debris from channels, but also sealing surfaces, sealing cracks, zone painting, replacing joint seals, though not the entire joint, removing large debris from channels. We see these preventive maintenance actions, preservation actions, as being in two categories: scheduled, but it means just that. There's a annual or biannual program for performing these actions, and it's the job of the agency to keep up and see that that program is delivered. Then there are evaluated actions, things that do indeed happen on a cycle, and probably a predictable cycle, but it is a matter of examining the bridge, examining the elements and their current condition, and determining if this year or the year after is the time to do some zone painting or to replace some joint seals. So certainly cyclic on a population level, cyclic on a planning level, but bridge by bridge, the owner wants to go and look and determine what to do and what years to do it in. Then we've got corrective actions. These are repairs, some big, some smaller. A lot of repairs are in kind. We're keeping a bridge pretty much in its original condition. So replacing joints, maybe of the same type, maybe of a different type, but certainly the same movement range if the structure is not otherwise being changed. If things need to be straightened after vehicle impacts, things need to be patched, certainly replacing painting. These are all keeping the structure or bringing the structure back to its as-built or as-new condition. Going together with corrective action are betterments and retrofits. So here we are making changes to the structure, but we're not improving load capacity, we're not improving traffic capacity, not adding lanes or changing clearances. But still we're modifying fatigue details, maybe changing out a drain system entirely so that it has more straight runs and so it doesn't clog as easily. Maybe modifying bank protection to move to better protection for banks, better systems for that. Possibly modifying continuity. That, eliminated expansion joint over a pier, and you're making the deck continuous and so on. So those are all considered part of preservation, though the bridge is not as designed any longer. It's being modified, but not in a way that changes capacity. So all in the preservation category. So we're putting together tables like this. We got quite a bunch of them in the guide. This one is an action set for decks. So these are our preservation actions. And the categories abbreviated here are shown. We've got preventive and corrective as the major divisions for the rows. And then within preventive, we've got scheduled preventive actions, evaluated preventive actions, and in corrective actions, we've got the in-kind work, and then the betterments and retrofits. Here for decks, there are certain things that we would do to all decks, certainly sweep and power wash. If the deck has a wearing surface, we'd maintain that wearing surface, seal cracks and so forth. And any deck, if it has a drainage issue, if things are clogging up or water's pooling on the deck, then of course that should be improved. So those things don't so much respond to what material the deck is made out of, they're just things we'd want to do on decks. But then separately, there are actions to take for a reinforced concrete deck, a slightly different set of actions to take for a steel deck, and yet a different set of actions to take for a timber deck. So there we get a bit more specific and identify actions that are preventive or corrective, that are scheduled or evaluated, and so on. So we get this organization of things to do to the deck. There's also kind of an age and a condition orientation to this. The decks in good condition, which are typically the younger decks, they're going to wind up in qualifying or being candidates for preventive maintenance. As the decks get older and accumulate some defects and accumulate some wear, they move into the corrective maintenance category. We produce a lot of these action sets. So we'll have some for approach, for railing, for deck, for joints, for drains, for superstructure, for bearing, treatment of the channel, mainly the channel bank is what we're interested in. substructure. And then overall bridge actions. Washing a bridge is all the components. So action sets for each of these guys, and culverts too. So an action set for culverts for preserving culverts. We have to give owners a way to measure the benefits of preservation actions, to know that certain actions are worth doing, to justify it to state government, to justify it to citizens, and to defend the budget that people want to have for preservation. So this is kind of a first step in the procedure we put together. We see a graph of present worth versus age. So bridges start out worth what it costs to build them, I guess. And that value is lost over time as the bridge deteriorates until the bridge has got some low value, maybe no value, and has to be replaced. We could look at portions of this curve. So we've got an interval, and during that interval, this could be arbitrary time period, 5 years, 10 years, 20 years, depending on how the owner wants to examine their evaluation of preservation. But in the interval, the bridge loses value. By wear, by use. So there's a monetary value that nobody hands you, and you don't collect it anywhere, but you've lost that value in the bridge. That value is available, maybe, to pay for the preservation. If a preservation action halted the loss of value in the bridge, halted deterioration, halted wear, and halt's a big claim, but it's the easy way to draw the picture. Slow is more like it, but if it halted the wear for that interval, then you've captured that value, and so we should be willing as owners to spend at least that amount to do the preservation work. So there's how we're trying to get a handle on where the money's coming from, where the value is coming from. This kind of approach gives us the result that it's a pretty good idea to invest money because there's value available. In younger structures, the value is lost more rapidly there for a given time period. But for older structures and structures in poor condition, there's less value available to preserve, to capture, to turn into a basis for preserving. We make the actual numerical analysis with annualized costs. So we have CT as a threshold. So we look at the replacement cost over the untended life, not unintended, but untended. What if you did nothing to this bridge, put it in service, and just let it run down, and eventually you have to replace it? Nobody treats a bridge like that, maybe local governments some of the times, but nobody wants to leave it completely without maintenance. So this is a notional cost. Then C sub 0 is the replacement cost for remaining life. This varies during life. As we're approaching the end of life of a bridge, we've got a replacement cost which isn't changing much. You know, it's whatever our current cost for building a new bridge is, but the remaining life is disappearing. So this C0 keeps increasing during the life of the bridge and goes up dramatically towards the end of life. And then CP, P is preservation. So what's the annualized cost for preserving the bridge? It's the replacement cost plus the action cost over the extended life. So what we're always looking forward to is, here's a bridge, we're going to have to replace it. How many years are left in its life? So the annualized cost to end of life is replacement over that remaining life. If we extend the life, you have to spend money. But if spending the money and extending the life together leads to a lower annualized cost, then it's worth doing. Right? So there's where we're picking up that value interval idea. The decisions have some boundaries. There has to be a net benefit. So the replacement cost, C0 without preservation, minus the annualized cost with preservation, that should be a positive number. The preservation cost is lower. And then the preservation annualized cost should not be above this threshold cost of an untended bridge. As we're doing these analyses, we find that almost any action, if it extends life at all, if there's an identifiable extension to life, it's worth doing. However, if the bridge is already near end of life, it's very expensive, even though it's worth doing. So we have to introduce this idea of a threshold to get to a point where bridges just shouldn't be preserved because they're getting so close to replacement. So we can do a quick example. This is part of our phase 1 report to the project panel. These cost numbers are from Colorado. We've been doing a lot of work for them, developing cost numbers and deterioration models for their bridge management system. So we've got a AASHTO bulb girder bridge here, typical of a lot of bridges in Colorado. The cost to replace the girders on this bridge comes out to be $420,000. That's only the girders. That's not the deck that would have to come off if you replace them. So this is a fairly narrow example. We look at the cost of replacing the joint seal on this bridge, and that's $7,200 for given the length of joint on the bridge here, and those seals have got to be replaced every 5 years. The 5-year number is coming from some deterioration model work we did for Colorado for their BMS. So we asked the question, we're worried about deterioration of the ends of the beams, the ends of the pre-stressed girders. And if they are deteriorated, we're probably replacing the girder. Not a lot of repair options. So if that begins to corrode and we're spalling off the concrete cover, we got a big problem. So the joint seal has got to be maintained. And so there has to be this $7,200 spent every 5 years to keep the joints in place and keep them watertight. So we start doing these annualized costs. So that very top line, joints not maintained, it's estimated that we're going to have severe problems, deterioration at the end of those bolt girders after about 40 years if the joints are never maintained. So we look at the capital cost of the girders over 40 years, and the annualized cost is at $10,500. If the joints are maintained, this bridge may last at least 75 years. It would appear that the life of pre-stressed girders is a lot longer than that if you keep the water off them. But we'll say 75 years. We are indeed taking the AASHTO design life there. The annualized cost of the girder drops to nearly half, $5,600, but there's an annual maintenance cost. That's the $7,000 odd joint seal replacement every 5 years. So that gets annualized too, so around $1,400 a year. So there is a net benefit of about $3,400, $3,500 a year to maintaining those joints. So the owner ought to maintain the joints. We looked at this bridge being unmaintained. The joint seals are allowed to deteriorate for 20 years, and then we pick up a preservation program at 20 years, and the preservation is aimed at making those joints watertight now and keeping them watertight afterwards. Well, part of the service life has already been lost. But we believe that we can get the girders to their 75-year design life if we pick up the protection of those joints, the watertight treatment of those joints at least 20 years. But all the costs are higher now. The annualized cost of the girders have doubled because we neglected it. The annualized cost, even with preservation of the joints, has gone up. So there's a benefit here, but not as good as if we had started earlier. So those kind of trade-offs, when to take preservation seriously, we begin to see in the dollar results. If the joints are not maintained for 40 years, then we're too close to the end of service life. You can maintain the joints, but there won't be a net benefit. So this kind of analysis, anticipating replacement of bridges, anticipating replacement of components, and looking at how certain preservation actions could incur an additional cost but delay the replacement, this gives us a basis for making an analysis. So here's some of the chapters and sections of the guide that we'll be putting together. We'll start with describing the elements of a bridge preservation program, giving definitions of standard terms, talking about how an agency should organize itself to support bridge preservation. You should have a bridge preservation engineer is kind of the nub. Then what are the bridge preservation actions? What we're calling preservation levels gets us into preventive versus corrective, scheduled versus evaluated. Bridge preservation programming, how should decisions be made to select preservation actions, to execute them, to see that they are executed in a timely way, how to identify repair needs and retrofit needs. We'll be discussing delivery of actions, not so much with recommendations, but just saying what's out there, using state crews, going to letting of projects to do multiple items at a bridge, and going to purchase order contracts, job order contracts, as needed contracts. States give various names to this thing, but it's the kind of a system where you set up a set of bid items and an indefinite quantity but agreed prices, and then you call on the contractor as needed to deliver that work. We'll look at evaluation of preservation action and programs, so keeping track of how well the preservation actions are doing and then how well the program is doing overall. Is the program achieving some net benefit? What can you do with maintenance quality assurance surveys to track that certain things like cleaning bridges are being effective? You may be sweeping a bridge every 2 years, but the MQA crew is out there anyway. Looking at the roadway, certainly, maybe or maybe not looking at your bridges, and so we'd want them to do that. Is the grit coming back to the curb lines in 6 months, and so your interval's all wrong? How can we use and take advantage of other information that sister branches of the agency are doing? How do we evaluate repair actions after they're in place? Are they holding up? What kind of cycle do we have for looking at inspection reports to glean information about the performance of the preservation actions? Costs and benefits, how should costs be captured so that we're getting good information on unit costs? We want to express these things in production units, element units basically, so that they're the most natural thing to use for preservation engineers in examining their programs. And then, of course, performing the cost-benefit analysis, we see that mainly as a prognosis, should we take this action. But once the action is taken, periodically that cost-benefit analysis should be re-examined and re-evaluated. Did you get it right in the first time? Looking at your recent past history of preservation and how the costs and benefits came out will make that process better and better and more reliable going forward in the agency. Data systems, what kind of data do we want to capture for bridge preservation programs? Pretty much we want to capture the maintenance history. Some states are doing a good job with that, others not, or doing a lesser job. Can we point to examples of systems to be imitated? There was an NCHRP process that developed a framework for a maintenance database for bridges, and so that's one option that owners that don't already have one could look at. And then performance measurement. This is partly for the internal use of the preservation program to keep track of what's happening. But a lot of it is to show outsiders, to show other parts of the DOT, other parts of state government, and the citizens. Here's what we are achieving. So how are we improving condition? Bridge status gets us into things like capacity and vulnerability. What's the productivity of the program? And what are the cost benefits? And then appendices are glossaries and definitions and references of the source documents. The source documents are coming from the states. A large part of our early work was collecting information on what the state practices are. The guide is going to be absorbing these state practices, organizing them, looking for similarities. We're not trying to invent new things. We're trying to see what is, what kind of the model activities and model organizations exist already that are best practices. Here's an example of some of the things that Georgia DOT does. This is from the Bridge Structures Maintenance Plan. And they've got certain actions that they perform at a regular schedule, a scheduled activity. So that's pressure washing. They do it at 10 years or at 15 years, depends on where the bridge is. The fall line's a geographic feature in Georgia. It pretty much divides the state in half, and the climate's a bit different, so they've got different intervals. Georgia also has a program for evaluating needs for actions. They've got this up at the policy level. So they make a formal decision whether or not to replace expansion joints at regular intervals, and that depends on what the truck traffic is. So we've got scheduled actions, we've got evaluated actions, and in fact our use of those terms came from our imitation of what Georgia's doing. Pennsylvania DOT has their publication 55, the Bridge Maintenance Manual, and this has been around for a while. They substantially updated it recently. They've got performance standards. What is a preservation action? What kind of crew do you need? What are the reference specifications and material standards that the DOT uses? What are scheduling considerations? What's the daily productivity? There's a whole lot more than a little just graphic I took out here, but it is kind of a cookbook. There are step-by-step procedures, but links to specifications you need, links to permits if that's going to be an issue for a given activity. So very good, very specific information on what the action is, how to perform it, how to record it, what's the basis for measurement. You'll also see up in the upper right the BMS2 Flex action. That's a serial number that ties it into their bridge management system, so they can get this activity recorded for a particular bridge, particular day, particular quantities, and particular costs. So a very good data organization in addition to being just a good way to present the method. Then we got Wisconsin. Bill was showing this yesterday, in fact, showing pretty much the same table. I've pushed around the headings a little bit to make it fit my slide. So this is Wisconsin DOT Bridge Preservation Policy Guide, and here we see deck joints, and what can the owner do for these? They can clean them, they can seal them or replace the seal, they can replace the joint, they can eliminate the joint. And those decisions are tied into the condition state for the joint, they're tied into the defects that may be present or not present, and then the condition states for the defects as well, and the anticipated extension to service life. So a very nice programmatic way of helping engineers select the appropriate actions. So we've been looking at all of the 50 states and collecting similar documentation. There are a lot of similarities about how people are approaching these things, and so the guide will try to put these all together and organize them and offer the summary of the best practices that we are finding among the DOTs. The thing we're working on right now this fall is collecting unit costs from states for preservation actions, so that as we do a set of examples for cost-benefit analysis, we can defend the numbers. You know, we say these numbers are coming from real owners. We're collecting a lot of maintenance histories so that we can look at bridges and see what was the age when a deck was replaced, what was the age when a joint was replaced, what was the age when painting was required. If an owner is putting overlays on, do they do it once in bridge life or 2 times or 3 times, and how far apart are those overlays occurring? And how did the overlay change? You know, initially it's a thin polymer overlay, later on it's a cementitious overlay, and so on. So we're looking at the maintenance histories to understand the intervals and to document and defend an idea of what interval is gained, what's that extension to life, which is essential to the cost-benefit analysis. We've got a bunch of states supporting us in this. We've got 11 right now: California, Connecticut, Georgia, Michigan, New York State, Ohio, Oregon, Pennsylvania, Utah, Virginia, and Wisconsin are all helping us with some or all of the information that we're trying to collect to defend and support and substantiate the ideas we're putting forward in the guide. So our schedule, we started last year. Our phase 1 was completed in March 2016, and the project panel had to review a report and so forth. We'll have our catalog of actions and a lot of our data collection done this spring. We'll have a draft guide out to the project panel middle of next year. April is the schedule. That may slip a little bit. These things always slip. And then our final product to NCHRP will be in the spring of 2018, and it's at that point, provided that the project panel believes it's a good product, that it would be offered to AASHTO to consider. There's a second piece to this. I haven't put it in these slides because we don't formally have it yet, but there is a second guide planned from NCHRP for deck preservation specifically. So very much the same approach and same set of topics that are handled here for bridges in general, but a detailed guide just for decks. So that's going to be added to this project as an increase to scope. That guide would come out the year after this project. So 2019, we'd have the deck guide out, but we'd be starting on it right now as soon as we get the contract signed is basically where we are at with it. So there's the project. We got a lot to do in the next couple of years. We're asking an awful lot of the supporting DOTs, but they've been very generous with us so far. That's the content of my talk. Are there questions?
I've never designed a bridge for an HS-20 truck. I started with HL-93. I know that there are people that started designing trucks at designing bridges for the H-15 truck. Is there some sort of a provision in your system of preservation that even though the superstructure may have a routine condition rating of a 6, if we have heavier trucks getting added as legal loads, is that gonna, I mean, can that work into your equation as to when to preserve and when to just let the bridge die, I guess?
Yeah, sure. I believe it does. I believe our process does handle that. We're not going to try to put a monetary value on that. That would get quite interesting, but also pretty complicated. That idea, bridges become obsolete, and not simply in the functional obsolescence sense. That's important. Clearances are important. Deck geometry is important. No question about that. But as legal loads increase, and even legal loads is a really slippery issue. So I'm going to take a digression here. So there's legal loads, and you can read state statute, and I read a lot of them because I had to study this at one point. And then there are overweight permit loads, which are certainly legal. They're in statute in many states, right? So legal loads means legal without a permit. So it's these overweight permit loads, in addition to legal loads, that have been increasing steadily, and there's always pressure to increase them more and more. And so as these larger vehicles and heavier vehicles are indeed using the roads, there are certain routes where they can't be permitted to go. They become a mobility issue. And that's a big problem. And so an owner should be looking at what routes are they going to send the heavy loads down? And what are the bridges like on those routes? And some of them are just too old and designed to too low a standard, so they should not be preserved. So we won't be putting a dollar value on them, but it gets us back to our earlier categories. What's the capacity of this bridge? Does the bridge have a capacity that we wish to keep in place, that the owner wishes to keep in place? And often or not, the answer is no. And so we don't preserve it or don't recommend it for such.
Okay. Thank you,
Thanks.
Dr. Hearn. Let's give a hand. Dr. Hearn.